Hi everyone, let's solve this problem, lowest common ancestor of a binary search tree. Let's understand the problem statement first. Given a binary search tree, find the lowest common ancestor node of two given nodes in a binary search tree. So basically you will be given a binary search tree and two nodes, you have to find the lowest common ancestor. Before we understand this problem statement, let's understand the terminology. We all know binary tree will have at max two children. It can have 0, 1 or at max 2 children. And binary search tree is nothing but the root node will have a particular value and all the values which are lesser than the root value will be on the left subtree and all the values which are greater than the root value will be on the right subtree. And there can be a case where there is a value which is equal to the root value. It can either fall on the left or right subtree, but for this use case you can just ignore that. Now let's understand ancestor. Let's consider two nodes 3 and 5. 4 can be an ancestor, 2 can be an ancestor, and 6 can be an ancestor. Anything which is able to connect two different nodes can be an ancestor. Let's take for example 4 and 5. If I take 4 and 5, 4 will be ancestor. If I take 2 and 4, 2 will be ancestor. 2 will be the lowest common ancestor. Now, uh, let's understand how we can code this. So let's say I have 2 and 8. They are on two different subtrees, left and right subtree. Then the node which is connecting them will be the lowest common ancestor, right? That is the answer. But if I have let's say 0, let's say I have 3 and 5. I am very sure that the root will not be the answer because 3 and 5 are all in the left subtree. I have all the values on the left subtree. That means there will be a different answer for that. I can ignore the root and I can ignore the right subtree. Now inside this particular left subtree, again I check 3 and 5. For 3 and 5, like are they falling onto the left subtree or right subtree? They are falling onto the right subtree, so I can ignore the left subtree and also the root. Now I am left with just this subtree. Now 3 and 5 are falling on two different sides, left and right. Then the node value will be 4. So that's the answer. Now let's also take a case of 2 and 8. So or let's take a case of 0 and 9 for better understanding. We know that 0 for this, but when we started the root level, 0 is on the left subtree and 9 is on the right subtree. That means root will be the answer, so we will just return the root. Now let's take the example of 7 and 9. We know that 7 and 9 are on the right subtree. We can completely ignore the root. We can completely ignore the left subtree. And now we can just focus on the right subtree. Now at this particular point of time, 7 and 9 are on two different sides for this particular node 8. That means I can just return 8. Cool. Let's also understand this edge case or a different use case. Here they are given a tree and we are given two nodes 2 and 4. In this case we can completely ignore the root and the right subtree and we will be left with just this particular subtree. Now again in this case we can completely ignore like we we cannot have 2 and 4 on the either left because 2 is the root node and we are checking for if 2 and 4 are less than the root value, which is not the case, so we can ignore the left one completely. Now we know that 2 and 4 are not both falling on the right subtree, so in this case my root will be the answer, so I will just return 2. So this is the use case. So now let's try to code it up. Let's say for example if any of the values are not given, we don't have to even proceed further and just return null from here. Otherwise, if p dot value is less than root dot value and q dot value is less than root dot value, this means the values are both the values are on the left subtree. So what will I have to do? I will have to call the same function by passing the left subtree, and I will pass both the nodes for further traversal. Else if my p dot value is greater than root dot value and then q dot value is greater than root dot value, then I will be returning the same function with root dot right, nothing but we are searching on the right subtree. But if this is not the use case, then we will be just returning the root. This is when the nodes fall on two different subtrees, or also when one of the nodes is the actual node where we are traversing. Now let's try to submit this, run this code first. Yes, it is successful. Let's also submit it. Yeah, it's successful. So now let's try to understand the time complexity and the space complexity. The time complexity will be, if it's a balanced tree, then it would be log n. Otherwise it can go up to n. So if all the nodes are like skewed tree, like 1 2 3 4, then it will be completely all on the left side of it. No, it will be on the right side of it, because 1 will be the root, 2 will be the left child and right child, and 3 will be its right child, and so on. So there can be like n levels of that tree. It can go up to n. Now the space complexity of this solution, we are not using any additional space here. It's just recursion. So we can say that it all depends on the levels we go of n. If we are not considering the recursion space, I think it is big of 1. Okay, I hope this solution is clear. Thank you.